Hello everyone, welcome to this video on logistic regression. Uh, Machine learning enthusiasts and machine learning practitioners know that logistic regression is one of the important machine learning regressions. But there is always a doubt as to whether it is a regression algorithm or is it a classification algorithm. Okay. In fact, this question is also asked in many interviews. Please tell me whether logistic regression is a classification or a regression algorithm, right? If you say it is a classification algorithm, then why the word regression is there? That question is also asked in some interviews also, right? So that is the question we will try to answer in this video. If you really see, if it is a case of linear regression, okay, we are talking of a straight line, right? It is also called as the line of best fit, right? That is what we indicate, in a linear regression. If it is a logistic regression, we are essentially talking about a logarithmic curve, or it is an S curve. Okay, a curve like this. It's also called as an S curve. This is known as logistic regression, right? This is known as the S curve. Machine learning practitioners will already know this. Okay, I'm giving this context because people seeing this video could come from different backgrounds. So to answer whether logistic regression is a regression or a classification algorithm, I must take you back in time. Okay, I must take you to the 19th century when the Belgian mathematician used the logistic sigmoid function. Okay, so many of the algorithms that we are using today are more than 50 and in some cases even 100 years old. So what is the difference, you may ask? Data availability is the key thing. Okay, data can be stored at a lower cost, data can be stored easily, and data can be retrieved easily, right? All these things are the factors that have fueled the rise of machine learning. We are making use of statistic principles, these models that have been around for a long time. Okay, that is true of not just logistic regression but of many other models also, right? So I'm taking you back in time to the 19th century. Okay, when Belgian mathematician he used the sigmoid function to study the population of microbes. He wanted to see how the growth of microbes is actually behaving. Okay, he observed that it followed an S curve, right? And that is the start of logistic regression, right? He observed that there will be an exponential period when resources are available in plenty, followed by a stationary phase or a cooling off period, and after that it actually declines, right? But he is interested in finding the peak population, right? So for that the S curve is more appropriate, right? And here what is he trying to find? He is trying to find population, right? If it is population, what is that? It is a number, right? If someone is trying to predict a number, what does it mean? That individual is trying to do a regression algorithm, right? Because in a classification algorithm, we are talking of categories, we are talking of classifications. Here, this Belgian mathematician was trying to find a number, was trying to find the population of microbes. So when I'm talking of population, I'm talking of a numeric, right? Which means it is a regression. Please understand that. So logistic regression is very much a regression algorithm, right? So please keep this in mind. Is fundamentally, I think a better way to put it will be, is fundamentally a regression algorithm, right? It is fundamentally a regression algorithm, but is used a lot in the world of classification, right? So please keep this in mind. Is fundamentally a regression algorithm only. Okay, fundamentally a regression algorithm. Okay, now how does the classification happens? Based on the p-value, right, or the probability value. If it is less than 0.5, right, if it is 0 to 0.5, if it is less than 0.5, if it is greater than 0.5 and less than 1, some classification is given, class A and class B. So the output is a p-value, right? and some thresholds or cutoffs are given for the p-value, and based on the cutoffs and thresholds, categorization or classification happens. So do you understand this? Okay. So logistic regression is basically a regression algorithm, right? We extrapolate that for classification. But do note that logistic regression is used more in classification, right? It fits very well. In fact, compared to even models like artificial neural networks, I have found that logistic regression gives better results, right? We will cover that, in a separate video, okay? Like when to use deep learning. That confusion is there among many machine learning enthusiasts, right? We will cover that, in a separate video. Today's discussion is about logistic regression, and we are trying to answer whether it is a regression or a classification algorithm, right? I hope this is clear to you, right? Logistic regression is basically a regression algorithm, okay? It is extrapolated for a classification algorithm, right? Based on thresholds that we give. Please note that. Can I give thresholds for 3 different levels? Yes, of course, right? This is a binary logistic regression. What I discussed here is a case of binary logistic regression. I can also go for multi-class linear logistic regression, right? Where I can have more than one category. Instead of A and B, I can have A, B, C, D, even E, right? So there are multiple categorizations possible, and I will have different levels of threshold. Okay, please note that logistic regression actually belongs to a group of models known as generalized linear model. Okay, so please keep this in mind. Okay, generalized linear model. So if you are asked this question whether logistic regression is a regression or a classification algorithm, say confidently that logistic regression is fundamentally a regression algorithm. Okay, it's been extrapolated for classification purposes. Just because it is used more in the world of classification doesn't mean that it cannot be a regression algorithm, right? Okay,